Good afternoon, hackers. My name is Burbage, and today I'll be presenting on beaconing malware adversaries. Let's go and dive in. All right, we'll go over our agenda for today. We'll discuss what is a problem that I foresee in the malware ecosystem. It's far too easy for these knuckleheads to go out and grab malware kits and utilize that to breach an organization. Then we'll go ahead and dive into how we're able to beacon malware adversaries. To understand that, I'll go over what is stored cross-site scripting, and then dive into the system itself. Talk about how we're able to inject beacon payloads into malware C2, and as well as receive those payloads and store them for later review. With talking about the system, I usually get a lot of questions about the legality of poking bears with this type of system. So I'll go over legality concerns, and then I have some case studies, and then we'll wrap that up with a conclusion and Q&A. So what is the problem? It's far too easy for anyone to go out to the internet and grab a malware kit. Not only are these malware kits available over the plain text or regular internet, as well as purchased for commodity kits, whether they're in vetted hacker forums or freely downloaded. And these breaches are occurring, right? It seems like Crabs on Security's telling people once a week that some organization has been breached. And current attribution, in my opinion, is one-sided, right? It seems to be grouped by shared infrastructure or shared malware code. So we need to have better attribution to defend against these attacks. And one way that we can do that is to beacon these adversaries as they utilize their malware command and control. So to understand how we're able to do that, I just want to briefly touch upon what is stored cross-site scripting. It's actually the most common web app vulnerability to date. Even more so in malware command and control, because these malware kits, they're not going through, hopefully, the rigorous testing that a legitimate software company is going through. And this mainly occurs whenever unsanitized input is stored, usually in a database within the malware C2, and then is later printed without any type of script filtering. So although it's possible to insert JavaScript within this particular system, we're solely doing benign image callbacks. And I'll discuss why that is here in a little bit as we discuss the legality concerns. I like to think of malware C2 interfaces, or malware C2s in general, having two distinct interfaces. There's the C2 API, which commonly referred to as the gate, right? This is where all of the infected nodes communicate to the C2. Malware C2, also known as a panel of the web application variety. And then the adversary or the actor is able to log into that C2 to view all of the infected nodes or to issue commands or to retrieve exfiltrated data. So it's important to note with this particular system, we're solely inserting beacons as if we were an infected node. So through that C2 API or the gate. And then whenever that admin logs in to view all of these infected machines, that's when they're triggering the beacon, calls back to our system when we're able to get some of that juicy intel attribution data. So when that C2 actor, the adversary, logs in, they might be greeted with a screen like this. This is an Amade loader screenshot from the C2 administrator. And one of these fields, all these different columns here that you see, one of the fields might be susceptible to stored cross-site scripting. So we're able to place our beacon callback within one of those fields, and then as that actor is looking at that, all of those victims, it's triggering a beacon reply, a beacon image back to that particular receiver for the MalBeacon system. And I'll show you what that looks like. So let's dive into the system itself. Again, we're using stored cross-site scripting to insert beacon callback payloads. And there's mainly two parts to this. There's the beacon injection, which also consists of two methods. So we're able to insert a beacon into the C2 by reverse engineering the malware family and finding those vulnerabilities within the C2. And then we also automated it a bit. So we modified Kuku Sandbox, and as that sample's running, we're able to hook some of those artifacts that are exfiltrated to the C2 and get information back. And then we have the receivers, just a image receiver that receives those callbacks. and this just simply logs the beacon data as the adversary generates that. A little bit of feedback there. Thanks. So let's go over the manual injection method. So this requires us to have a copy of that C2 source code, So this might be one of the malware kits that are freely available to download, or one of those kits that were once sold in underground forums that has since leaked. We can study the C2 source code for these stored cross-site scripting vulnerabilities, and then write a fake bot or emulator as if we're checking in to that C2. So there's pros and cons to this method. Is that it's very sniper-like precision, and which leads to a very high callback rate. But the cons to this is that it's very time-consuming, especially if that malware family is under active development. The malware author might change how those bots are checking in, and you have to go back, reverse engineer that protocol, and rewrite your the manual injection payload. Show of hands, I'm sure quite a few people in here are familiar with Kuku Sandbox. Good, quite a few people. So those aren't too familiar. It's just an open source sandbox solution. Runs on top of Python, right? So you can execute samples within a virtualized environment. The way that we do the automated injection is that we modified Kuku's monitor. So as that malware sample is running within the VM, it might request certain artifacts about the machine, like give me the machine name that I just infected, or give me the username. We hook those Windows API calls, and on the return of that, we taint the response with our beacon payload. Again, that might be one of the items that are submitted up to the C2, and if the C2 is vulnerable to stored cross-site scripting for that field, that's when we achieve the beacon callback. So the pros of this is that with any type of sandbox solution, it's highly scalable. We can do massive scaled out distribution of Kuku. And then it's not affected by malware changes. So one of the families I'll talk about within the case studies is a KPOT info stealer. And although the authors behind this particular family, they were changing the check-in protocol monthly with different encryption schemes, I was still able to put those new samples into Kuku Sandbox and still get callbacks without having to reverse engineer the check-in protocol to write an emulator for it. So it casts a wider net, and it's more or less like a spray and pray method. And the cons of this is that it can be quite noisy, right? So as you can imagine, so in the event that the malware family is not susceptible to callbacks, the C2 just drops that as a bad packet. Worst case scenario is that the particular field's not vulnerable to stored cross-site scripting, so whenever the actor is viewing all of the infected victim list, they might see your callback payload not rendered properly, and they would be able to see that. So that would obviously be OPSEC issues there. And then, so all of the beacon payloads are submitted to the C2. The actor logs in. He triggers an image request back to our systems, and we're able to record that information. And that's just a simple image server, really, that we stood up, running on Apache with a htaccess redirect for any type of image request. Send it to a PHP script, then I pull out all of the headers and source information. So what do we get from an image request? Pretty interesting, in that when I first started looking into this, how much information advertisement companies are getting on each and every one of us. It really opened my eyes up. So everything from the source IP, we can geolocate that, of course. The HTTP referrer field is very interesting in that this is going to be the URL that the actor is currently accessing the malware C2 at. So especially with malware families that might have a proxy layer in between what infected nodes communicate with and the C2, we're able to see the actual admin backend systems that they're utilizing for C2, which is always pretty neat. And then with some of the manual injection methods, I'm able to submit a UID parameter. This is really cool too. You could start tracking different malware families, again, with multiple proxy layers in between what infected machines communicate with. Then some of those free like HTTP, HTTPS proxies that exist on the internet, they actually leak the true source IP address of the people that are utilizing that. So if we see those client IP headers, we rip that out and store those as well for later review. And then the user agent too, right? And these client headers, they can be spoofed, but in the event that the user agent is true, that tells us a great deal of information about our attacker, right? Everything from their architecture that they're utilizing, x86 or 64-bit, what operating system they're running, and even their web browser preference, as far down to whether or not they're utilizing a desktop or a mobile device. So the receiver just records all this information and then replies back with a 1x1 pixel image. The reason why we're sending back a 1x1 pixel is that as long as that beacon payload renders properly within the C2, the actor's none the wiser that just a tiny pixel, transparent pixel, is rendering within that malware screen that they're looking at. And then back in March, I was talking to JB and some of the guys from like Roadhouse, and they were discussing, well, why aren't you setting a persistent cookie into the reply of that image request? And that's exactly what I implemented, and it's coming back with some really cool data. So these guys are able to change, the malware C2 URL. They're able to utilize different malware families, and as long as we've had a persistent cookie set for that browser session, we're now able to track these guys and cluster that into essentially threat actor groups that are utilizing, multiple different host names or, domain names, IP addresses, and different malware families. So the largest cluster that I pulled out of the data set has some strong overlaps with what Unit 42 is calling a Silver Terrier. Silver Terrier is a West African group mainly conducting BEC attacks, but they've been known to utilize multiple malware families, everything from LokiBot to Formbook to Agent Tesla. The list goes on. Pretty much anything that was once advertised in malware communities in the Russian underground and has since leaked, these guys are utilizing it. So let's go over legality concerns. I went several rounds with these guys, actually, EFF, Electronic Frontier Foundation. And the word that I got back from them is that as long as I'm not doing any type of code execution, it should be fair game. Well, what is code execution in this case? That would be considered JavaScript, which was kind of a letdown because I can tell you that the first thing I was doing when I was playing with this system, starting over 3 years ago, was doing JS callbacks. And would do some pretty crazy stuff like, give me, as long as the person clicked accept, I was like, give me access to your web camera. And they would click accept, and I would take pictures of these guys, behind their malware C2. But the word back from them was like, code execution's a bit out of bounds, so I stuck to benign images. And this is no worse than advertisements, right? I bet each and every one of us, if we pulled up, the raw email source on our phones, they have these, tracking pixels to see whether or not you've opened email. So same thing. No authentication bypass, right? So we're solely inserting these again through the, typical traffic that would occur as if we were an infected device. And the only way that you're able to trip the beacon is if you're one of these malicious adversaries that were logging into the C2 and then firing those image callbacks. So you would not be tripping these beacons, just by searching for blow-up dolls on Amazon, if that's your thing. But hey, let's go over some case studies here. First one I'll talk about, I believe BlueLive calls them Air9, and I think Talos calls them TA545. So back in January of 2018, again, I've been collecting this data for over 3 years now. These knuckleheads were utilizing online or spam bot to send malicious emails with CanadaPost.zip attachments. The zip contained R's VBS loader. It's just a commodity malware kit that was sold on Russian underground forums. And whenever that victim clicked on the VBS, reached out to the C2 pictured right there, the admin interface, and requested, what additional malware would you like me to download and execute? We call these families loaders, right? So R's VBS loader. In these particular campaigns, they're loading Canadian banking Trojans. and also downloaded Zero Evil Info Stealer. Zero Evil and R's written by the same author, by the way. So got some pretty interesting callbacks on this, tracing back to a VPS that was hosted in the UK, right? So Five Eye friendly nation there. So the Canadian cert bubbas were interested in receiving that piece of information. Second case study. I mentioned K-Pod earlier. So back in September of 2018, and this is actually an ongoing threat, is where these knuckleheads, they'll go out and take a look at what popular crypto coin software exists out on the internet. They'll stand up a fake copy of that particular crypto software website, and then either by advertising that malicious link in crypto forums or just relying on Google SEO, victims will browse to that website and download malware as opposed to the crypto coin software. In these particular campaigns, it was downloading K-Pot, actually pronounced krot, which is the Russian word for mole. These pointing back to a VPS provider in Russia. So this particular system has not only worked with commodity malware, but has also worked with APT, Advanced Persistent Threats. So back in January of 2019, a piece of mole rats malware came across my desk. And this is one of the samples that I tossed into the modified Kuku Sandbox. Didn't have to reverse engineer the C2 check-in process. Didn't have to write an emulator. Just simply tossed it into the sandbox. Artifacts that were gathered, from that VM were submitted to the C2. One of which being a beacon callback, and sure enough, received some beacons back from this particular actor. So some pretty good attribution on this, pointing back to or geolocating rather, to a residential ISP in the Gaza Strip. And of course, this malware family being attributed to the Gaza cyber gang. One other interesting artifact, or a couple rather, is that this malware family had multiple proxy layers in between what the infected nodes communicated with and what the actual admin backend was being utilized. So it was able to see, beyond that entire proxy layer of infrastructure, and we're able to enumerate that actual admin interface that you see down there at the bottom. And in order to access that interface, you also had to have this particular user agent set of twos. So I thought that was a pretty unique hard-coded artifact, and sure enough, searching that string across social media profiles may or may have not found a couple individuals associated with this Gaza cyber gang. All right, fourth case study I'll go over. Back in November of 2019. And the reason why I pointed this out is that, a lot of these guys that are participating in exploit kits, as you can see, especially with RIG, they'll within the same campaign drop, 7 or 8 different malware families. So the question that I wanted to answer out of that is, are these people that are conducting the exploit kit campaign, is it the same actor that's utilizing all of these malware families, or is it someone that's renting access to that and using that as like a loader service, so anyone can contract them to deploy whatever malware they want? And the latter seems to hold true in that a couple of the malware families from this particular RIG exploit kit campaign that we were beaconing came back with 2 distinct actors with those particular families. So just thought I'd point that out. It's pretty interesting. So you can utilize this, to gain further intelligence about, large-scale, campaigns, especially from exploit kits and other different campaigns that exist in the wild. So go over some current statistics. So these are actually a little bit low since I burnt these slides, I think, about a week and a half ago. So going back over 3 years, again, over 380,000 beacons that I've received from bad guys. That's a page load each time, one of those beacon pixels are sent to my system that I count as one beacon. Adversaries over, I think now just over 30,000 unique source IP addresses, and Malware C2 instances over 35,000. So it's been a really fun project to work on. And big thanks to one of my buddies out that I met on Roadhouse, Chris Cork. He actually redid the front end. So just wanted to give him a quick shout out. Can everyone say thanks, Cork? Thanks, Cork. All right. He'll appreciate that. Thank you. Just over 2 weeks ago, I started to enrich the source IP addresses that were coming back. And I know, most folks in here probably have better access to, some of the source IP, reputation or geolocation databases that I do here. But some pretty interesting, I'm able to do things like give me the top 10 ASNs from Adversaries. So starting to look into that. The reason why, a lot of this is coming back is Nigeria. One of the largest families that I'm able to collect on right now and have been since, going back to 2017, 2016 is LokiBot. So again, tying that into the Unit 42 Silver Terrier guys. So a lot of LokiBot still in use today. And we're able to do silly stuff like what are the top 10 cities of Adversaries currently living in, everything from Lagos to London, apparently. New York City was on there, which is surprising. But yeah, it's more than likely probably some type of VPN exit. But again, it's I do get asked the question fairly often, well, are you just collecting VPN exit nodes? To which I have two responses. So understanding that your adversary is utilizing a particular VPN is pretty good, I think, intelligence aspect in of itself. And secondly, what I've seen is although some of these bad guys, they might be utilizing proper OPSEC coming from their desktop, they're looking at load infection rates from their mobile device as they're out in town. So we'll see that with two distinct callbacks. The user agent will be pointing back to a desktop user agent over a VPN, but then they're looking at their C2 from their mobile device out in town, and that's being accessed, from cellular tower IP callbacks. So always find that pretty interesting. So in conclusion, I would really like to get my modified monitor, Kuku, out on any large-scale Kuku deployments. So if anyone in their shop is running Kuku and you wanted to participate in the project, I'd be very interested in talking to you. And JB is very cool. I've been working with him the past week or two that runs Phoenix Sandbox, and we've just implemented it there. So looking to get some really cool callbacks utilizing Phoenix. The reason why the Kuku Sandbox is so important is that as we start to get callbacks from the automated hooked samples, I'm able to dive into the particular family and spend time reverse engineering that to write those emulators, and then that of course just enriches the data from there. Starting to work with data scientists like Beth, her group that are doing clustering and stuff around the especially like the beacon data, the cookies that are set there. And I'm happy to report that we just got a feed together within the past week or two. So if you're interested in pulling this data into your MISP or your SIEM, don't hesitate to reach out. Researchers can access an account on the front end. This short URL just goes to a Google form, not to a Rick roll or anything. Just prompt for a couple pieces of information just to verify that you're a researcher, and I delete that data after the invite's sent out. That about it? Thanks for having me. Do we have any questions, concerns, bitches, gripes, moans, complaints?
We were seeing some Osiris banking malware with the same Canada Post sort of MO. I was curious to hear if you had seen that.
Just recently, or?
Not recently.
Yep.
Probably a few months ago or so. Around that time frame, we had come across quite a big campaign.
Yeah, it's interesting. I know that it's a particular template that a lot of these guys are utilizing that are targeting Canadian financial institutions users, and they're mainly utilizing the online or spam bot to pump those out. But I'm not too familiar with the exact campaign that you're referring to. Did you happen to catch what the end?
They had a really, really interesting loader. 0 hits on VT. There were side loading, some a legitimate application using a DLL, like side loading, right?
Huh.
Had no detections. It was a shellcode loader, which detections for aren't always as good for at the moment.
Yeah.
So it was encrypted shellcode, right? So injected into memory, launched up, then spawned Osiris. But had the same MO, like Canada Post, tracking number.exe, same sort of idea. So I thought that was interesting.
Yeah, I'll have to see if those campaigns line up. But yeah, happy to share any type of data with you that I gained on the guys, if that helps.
Yeah, that would be great. Maybe we'll talk later.
Cool.
Thanks.
Yep.
First off, awesome talk. That was a really cool idea.
Thanks,
Great
man.
to see the stats behind it, too. How many malware samples did you have to detonate to get those stats that you have coming out on the other side?
Yeah, unfortunately, I haven't really dove into, just because I'm slowly, starting to open up the Kuku infrastructure. I don't have good percentages now as far as what's susceptible and what's not. But although, I would say this particular method's only, it only works in the event that the C2 is utilizing, a web application stack, as opposed to like these rats that might exist, on a host operating system, and the actor has to like port forward that particular port, for C2. But that's a good question, and I hope to answer that soon. As far as give me the percentage of callbacks that you receive, from a month's worth of samples or something like that.
Awesome. Thank you.
Yeah, man.
I think we got time for one more. Okay. Thank you very much.
Yeah. Thanks for having me.
All right. Is Pedram out there?